Okay. Hi, my name is Emma Kitchen, and this video, I'm going to be using option 2, which is just going over notes by myself. So, I'm going to be focusing on, inferential statistics, probably more this, the first section of this last chapter that we just read. Yeah, so I'm just going to be focusing on that. Hopefully these notes make sense to you guys, and it helps you out just like talking through them. So I guess the first thing to kind of think about is inferential versus descriptive statistics and what the difference between them is. So we've talked a lot about descriptive statistics, which is basically just describing what you see in a sample. Just like, the range, the minimum and the maximum, the different skews, all that stuff. You're just describing the data that you see. So that's descriptive statistics. What I'm going to be talking about a little bit more is inferential statistics. And inferential statistics are taking the results that you got from a sample and being able to apply them to a wider population. And this is really the goal of studies, right? Is being able to do studies and then show that it applies to lots of different people, not just the people that you studied. So inferential statistics are really important and really useful. A couple things that you kind of have to have in order to do inferential statistics is you kind of have to, your population has to be normally distributed. So that looks like that perfect bell curve, that obviously wasn't perfect, but bell curve, right? So most people in the middle and then only a few on the outside. And that's just like a normal distribution. You also have like bimodal, trimodal, which has like 2 or even 3 bumps. And that just doesn't work as well. So normal distribution is really what you need. And then the other thing with inferential is you're assuming that your population was picked randomly. So you're assuming it's a good representative sample of the population. It's normally distributed. And then you'll be able to put to use inferential statistics. Whereas, descriptive is just kind of describing what you see. Let's see. I want to talk about the 68, 95, 99.7 rule because I think it's really important. So if you're thinking of your normal bell curve, 68% of that data is going to fall in one standard deviation of the mean, so right in that middle. Then the 95%, is going to fall within 2 standard deviations, and then 99.7 is going to fall within 3 standard deviations. So 3 standard deviations is going to cover a lot of your data. 2 is at 95, 1's at 68%. And the thing to really remember about this is that you really want to focus on the 95%. Social sciences, you shoot for that 95% range. So you know that within 2 standard deviations, 95% of the population is going to fit what your data shows. So you really want to hit that 0.05 confidence interval. You're saying that you have confidence that 95% of the population is going to fit in that data set or range. So 68, 95, 99.7 rule is really important. So kind of going along with those intervals, we talked about the p-value, which is really important in this class, focusing on the p-value and what that means. So we talked about it like running chi-square tests, how getting a p-value, the lower the p-value, the more reliable it is. So you want to have a p-value that's under the 0.05, that 95%. If it's even lower, then great. But you don't want above, because then you can't be as confident that your data is going to fall within the range that you want it to. or catch enough of that population to be representative of the whole population. So 0.05 is a really big number to keep in mind when you're talking about p-values and if your result is significant enough to accept that result. The goal of our studies is to reject the null hypothesis, right? The null hypothesis is no change, basically. It's if, I don't know, a quick example would be like, I think on our last quiz it had one that was like male and female, if there's any correlation between if they have a cat or a dog. And a null hypothesis would be there's no correlation, whereas your hypothesis might be like, yes, there is a correlation between, females are more likely to get dogs. So anyways, you want to reject the null hypothesis. We want to show that something has changed. We want to show that, yes, we did see something that has changed, and yes, it can be representative for everyone. And if your p-value is under that 0.05, then you can reject the null hypothesis and accept the alternative hypothesis, which is what you wanted. So 0.05, really important. Then you start thinking about if your result is significant. What if you mess up, right? What if you make a mistake in determining whether your result was significant or not? So these are type 1 and type 2 errors. Those are the two types of errors that you can make doing this, going over inferential statistics. Type 1 error is like a false positive. So basically you're saying that you found a result that was significant when really there was no significance. This is considered the more like the worst error to make, because like instead of doing nothing, instead of accepting that like, yeah, there was no change, you accepted that something did change when it didn't. And so that can really affect people if you're doing like medications or something like that. I guess that doesn't really fall under social sciences, but still. So false positive is definitely the more like less forgiving error to make. It's also, I think one of the videos explained as type 1 error is entirely your fault, right? So that's kind of a lot of pressure, but basically it's saying that what you did something wrong. The researcher was at fault for creating this error. So definitely you want to avoid that type 1 error. It's not good. The other type of error is type 2, which is that there is something significant in your results, but you decided that there wasn't. You accepted the null hypothesis. Which this can still be bad, but not quite as bad. I mean, you were still wrong, but it's not like hurting anyone, really. It's not doing anything. You didn't change anything. So it's not that bad. And like in the video, it kind of explains that type 2 error is more maybe a fault with like the sampling or something like that. It's less like totally the researcher's fault, and a little bit more just about the sampling and other things going on. So you can kind of sleep at night better committing type 2 error instead of type 1 error. Yeah, I think that's just about all I wanted to talk about. I think that inferential statistics are really cool because, like, I don't know, I think it's cool to be able to think about and see how, like, such a small population, like, researching about such a small population can, like, cover a lot of people. I think it's really interesting that humans kind of, like, follow patterns in that way, and that you can kind of see what people will do or how people will react based on what other people do. And then being able to use, like, numbers and statistics to be able to, like, calculate that is pretty cool. So, yeah, I think that is about it. So, see you next time.